This is the CCEA Maths paper. This is M7 paper 1. It's a non-calculator one and it's from November 2021. Let's take a wee look at question 1. 800 students attend Clarendon College. 15% of them are in year 11. 10% of the year 11 students are in the Spanish class. Of all the students in Clarendon College, how many are not in the year 11 Spanish class? So 15% of 800 is effectively what we want to do. So hopefully you can see, non-calculator obviously, so 10% would be 80, 5% it would be 40, so that means 120 are going to be in year 11. 10% of the year 11 students are in the Spanish class, so we want then 10% of 120, and that's obviously then equal to 12. So of all the students in Clarendon College, how many are not in the year 11 Spanish class? So that's going to be 800, take away 12, and that gives me then 788. Question 2. Each new member in a sequence is found using the rule multiply the previous term by 3 then subtract 5, find the next two terms. So times by 3 gives me 6, then subtract 5 gives me 1. Times by 3 gives me 3, then subtract 5, and I end up then with minus 2. A bag contains 5 counters, each one a different colour. There's red, green, blue, white and yellow. Daniel takes a counter at random from the bag. Daniel now tosses a fair coin. One possible outcome is red and heads, which could be written red and heads. List all the possible outcomes for this experiment in the two-way table below. One's already been done for you. So these are all the heads ones here. So you could have green and heads, blue and heads, and white and heads, and yellow and heads, and then the same for tails. So red and tails, green and tails, blue and tails, white and tails, and yellow and tails. What is the probability that the outcome is B and H? So that's 1 out of 10. What is the probability the outcome of the experiment contains a green or a tail or both? A green or a tail or both. So we could have that one, that one, that one, that one, that one, because they all contain tails, and then the green ones are that one and that one. So how many of a circle there? That's 6. So that would be 6 over 10, which cancels down then to 3/5. Mike is out for a bicycle ride. He starts from home. The graph shows the 4 stages A, B, C and D. Which stage of the graph shows Mike repairing an early puncture? Well, quite early on here, he is between 10 minutes and 20 minutes. He isn't travelling anywhere. So then that's got to be B. What is Mike's average speed during stage C? Okay, well, he travels for between 20 and 40. So he travels there for 20 minutes. And the distance he travelled then is, so he goes between 7 there and 1. So the distance that he's travelled is going to be 6. So he does 6 miles in 20 minutes. So how much then would he do in an hour? Because I want here miles per hour. So he would do 18 miles in 60 minutes. So he's doing then 18 miles per hour. Mike travels home at an average speed of 14 meters per second. Complete the final stage of Mike's bicycle ride on the graph. So 14 miles per hour. Well, if you have 7 miles to travel home and he's going at 14 miles per hour, he would do 14 miles in an hour, so he would do 7 miles in 30 minutes. So we want to go for 45 through then to 75. Would be what we're looking for 45 through to 75, because that would be 10, 20, 30 minutes. So we want to join it up then like that. That's us. Question 5. In the space below, make a scale drawing of the diagram ABCD shown above. Use a scale of 1 centimetre to 50 metres, and they've given us our kind of starting point B, then down here. So let's see, if B starts here and we have 400, so going across there we're going to have 400, we're going to have 650. So 650 meters is going to be then, let me see, so for every 100 it's going to be 2 centimeters, so it's going to be 12, so it's going to be 13 centimeters then going across. So we're going to have then that point there. At the 400 mark, so then that's going to be my 8 centimeter mark. We're going to have this going up here, and we need to get a 90 degree. Now there is a way of doing this with a compass, but I'm going to use my protractor to get a nice straight 90 going up there. And then I'm going to mark this line on here, and then work out after that how long it needs to be. In fact, no, we'll work out how long it needs to be first. It's 300 meters and 50 meters for each centimeter, so it needs to be 6 centimeters long. Sometimes it's easier to draw the line in first, and then do that. And there's my 6 centimeters long, and then that's going to be my point A. That's my point D, and that's my point C. And then simply join these up to get the rest of them. So you end up then with that. Use your scale drawing to calculate the actual length of AB. So AB, it looks to be right on 10 then, doesn't it? So 10 centimeters, we'll times that then by 50, so that's then going to be 500 meters. That's us. Question 6. This recipe makes 16 scones with the following ingredients. Paul wants to make 20 scones. How much butter will he need? So he has 40 grams of butter for 16. 16 is going to be 40 grams of butter. So obviously then for 4 people we would divide by 4. It would be 10 grams of butter. And so then for 20 people we would times that then by 5, and we get 50 grams of butter. 50 grams of butter. Paul has 300 grams of flour. Has he enough flour to make 20 scones? Let me see. So here 250 grams would be 16. So for 16 people it would be 250 grams. So I guess, and he's trying to make kind of, he has 300 grams. And he wants to try and make 20 if he can. So if he has 16, he'd need another quarter of what he has here to get this. So we need to work out then a quarter of the 250. So half of the 250 would be 125, and then 125 divided by 2 is going to give me then 62 and a half. So he would need 250 plus 62 and a half, which would be over 300, so he doesn't. So my answer then would be no. So he only has an extra 50 grams from the 250, but he needs that, so he needs another 12.5 grams. There's a shape here, and then it's just so it says, on the grid above, translate the shape P 6 to the left and 5 down, label the new shape Q. So 6 units to the left and 5 down. So we take a particular point here and move them 6 to the left and 5 down. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5. And you can either move every point or just see the pattern and try then to fill that in. I'm just going to look at the shape of it. And it tells me then to label this new shape Q. On the same grid, rotate this shape P 90 degrees anti-clockwise about the origin. So on the same grid, rotate the shape P 90 degrees anti-clockwise about the origin. Label the new shape R. So for rotations, we need some tracing paper. That makes your life an awful lot easier. If you don't have any tracing paper at home, greaseproof paper works very well, and that's what I've got here. So if you kind of set it up and try and set it up so it looks kind of nice and straight. It's awkward if you kind of do it like that, because then it's harder to see where you've rotated 90 degrees. So we get our shape here, and then we just draw over it. Try not to let it move, obviously, just to be as accurate as you can. So there's my shape. Drawn on now, and then I put my pencil neatly at the origin, and I rotate around anti-clockwise and see where I end up. So that's me rotating there, and hopefully you can see then where the shape is due to go. We then need left, so it's a point minus 2, 4 is one of my corners there. And you can pick on another few corners if you want, so that's going to be minus 4, 6. And then I can see some of the other shapes then from there and where they need to go. I think then that should give me my correct shape. So if I join these up, again, nice thick lines so you can see. And I have to label this new shape R. That's me. Question 8. A 6-sided dice is biased. The table below gives the probability of getting a 1, 2, 3, 4, and 5 when this dice is rolled. Work out the probability of getting a 6 when the dice is rolled. So we just need to add these together then and take them away from 1. So you can do it in your head if you wish. It's not too hard. Actually, add these up. So 0.13, 0.17, they add nicely to give me 0.3. Plus 0.2 is 0.5. Plus 0.11 is then 0.61, and then that's 0.75, so that one then is going to be 0.25. Sometimes good to put in a wee bit of working out. So it's going to be 1 take away 0.13 plus 0.17 plus 0.2 plus 0.11 plus 0.14, and that gives us then 0.25. On to question 9. It's inequality then to solve, so we need to add 1 to both sides. Gives me 2x is less than or equal to minus 4. And that means that x is less than or equal to minus 2. X less than or equal to minus 2. Show your solution on the number line. Less than or equal to minus 2. So it's going to be a solid dot here. And then my line going this way here. Facing there. Question 10. Use graphs to solve the simultaneous equations y equals 2x plus 1 and y equals 10 minus x. The graph of y equals 2x plus 1 has already been drawn for you, so we need to try and draw the other line on and then work out where the two lines have crossed. You can either set up a wee table of values, so a table of values would work out like that, x and y, 0, 1, 2, 3, 4, 5, sub in those numbers into this here, and you would get it. The way I'm going to do it, however, is use the gradient and the y-intercept. So it's kind of in the form y equals mx plus c. You need to be careful with this one here. C is actually the y-intercept here, so I know it crosses at 10, and then minus x means it's a gradient of minus 1. So I go across 1 and down 1, across 1, down 1, across 1, down 1, and I plot my line then like that. So there's my line, and there is the point then that I'm looking for. So that is the point 3, 7. So the x coordinate is 3 and the y coordinate is 7. So it's 3, 7. Question 11. A spinner has sections labelled A, B, C and D. The spinner is spun, excuse me. The spinner spun. The relative frequency of landing on D is recorded after every 10 spins. Some of the results are recorded in the table below. 0.5, 0.3, 0.4, 0.35, 15 that. After 50 spins, the spinner had landed on D 19 times. Fill in the relative frequency in the table below. Well, if it's 19 out of 50, that's the same as 38 out of 100. So it's going to be 0.38. How many times had the spinner landed in D after 60 spins? So it's going to be 45 out of 100 is what we have there, and we need to make that into 60. So they both divide by 5, so that then would be 9 over 20. And then that's the same as 27 over 60. So the answer then would be 27. Do you think the spinner is biased? Give a reason for your answer. Well, if you look at this spinner here, it's kind of like I think that's supposed to be a square, so you would expect it to be 0.25. And so with the 60 spins, I'm expecting about 15. About 15 times, so the relative frequency should be like 0.25, you know, like a quarter. So I think it's looking like it's biased. So, do you think the spinner is biased? Yes. I would expect a relative frequency of 0.25 for D, and it's too high. If the spinner spun 400 times, how many times would you expect it to land on D? So it's going to be 400 multiplied by 0.45. That maybe looks like quite an awkward one to do, but if you think it's kind of 45 for 100, then we got to do just kind of 45 times by 4. 45 times 2 is 90, so 2 90s in. We're going to give me 180. On the grid, reflect shape S in the line y equals x. So line y equals x is a special line. You can do it a couple of different ways. It's one where the y coordinate is the same as the x coordinate, or it's the one where it goes through the origin and has a gradient of 1. So if you want to fill in, so 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. So that's the line y equals x. So I'm trying to reflect it in that line there. Some people like to turn this round, so it's sitting like that, and then it's easier to reflect. But we're going to just kind of reflect across. So that is half a square away. So this point is going to go here. It's all about kind of perpendicular working lines. So that's kind of wee working line there. So that'll be 1.5. So I go 1.5 out this way. This is 2. It's going to go 2. This is going to be 1, 2, 3.5. So half, 1, 2, 2, 3. That's that point. I've done that point, and then this point is 1, 2. So this is 1, 2, and that's my shape. That's my shape reflected then in y equals x. Question 13. Andy and Zoe have the same rates of pay. Andy works 12 hours normal time and 8 hours overtime and earns 238. Zoe works 10 hours normal time and 15 hours overtime and earns 315. Calculate the rates of normal pay and overtime pay. A solution by guessing effectively isn't allowed. So I'm going to call normal time x and y and x and y. So it's going to give me then 12x plus 8y is 238, and then 10x plus 15y is 315. You can do this a couple of different ways. This does cancel down to make your life a little bit easier. It does kind of divide by 5, so you might want to do that, and I think then it might kind of go in a wee bit easier. This looks as well, and we go into 220, divides by 2 anyway, so we'll make it slightly easier to start with. This divided by 2, 6x plus 4y equals, what's half of that? 119. I'll call that number 1, and then divide that one by 5. 2x plus 3y, and then 315 divided by 5. We'll just not worry too much about this. So 15 divided by 5 doesn't goes in 6 times. Gives me then 63. And that's 2. Now, of course you can just multiply up, make this into 120. Totally fine. There's no issues with that. To be honest, it's maybe easier. But this way should work out okay for us. So I'm going to times this one here by 3. 2 times 3 gives me 6x plus 9y times by 3 then is 189. My equation 1 is 6x plus 4y is 119. Subtracting these, then I get 5y is equal to, so it's 80 take away, so that's 70 I think, and divide then by 5, I get y then is 14. If I substitute that in then to this one, so I've been to 2x plus 3y is 63. 2x plus 42, because that's my 3/14 is 63. 2x then is, take those away, I get 21, and then x is 10.5. So my normal is X, so it's £10.50. And my overtime then is 14. Those are my two answers. Final question then. 1 million centimeters cubed of gas has a mass of 1.5 times 10 to the power 4. Given your answer in standard form, calculate the mass of 1 cubic centimeter of gas. So I need to divide this by this. So it's 1.5 times 10 to the power 4 divided by this. So that's just 10 to the power 6. So I want to then subtract the two powers, and that gives me 1.5 times 10. Remember, I subtract the powers here to the minus 2.